Hi everybody. This is a short video that was requested by one of your classmates. And basically there was a question about getting a little bit of math help with the errors with having a pole out of plumb using a GPS survey. So the first thing is I want to apologize for not having a webcam today. It's just not set up properly, so I just decided I would do this voiceover instead. And what we're going to refer to is this file. These are for problems 15.6 to 15.9, but if you open this file on your web page, you'll see that I've made a drawing which is clearly not to scale. But this is the nature of the problem. We have, in the first example, the first couple examples, a 2-meter tall GPS pole. And now if it were perfectly vertical, there would be no error in the horizontal or the vertical direction. But what happens is this point, when you put the pole down, this is the point that's being measured. So if the point here is not exactly 2 meters, exactly fully vertical from that point, there's going to be a little bit of error. So what happens if you launch the pole over, and this is greatly exaggerated, it says that it's out of plumb or out of vertical by 10 minutes, which is 10 divided by 60 degrees, 1/6 of a degree. So it's not very much. But basically what happens then is the pole remains 2 meters long, but what happens is it used to be here, the top over this point used to be here, and now it's here. Because if you think about it, that 2 meters is the hypotenuse of a triangle. And this is 10 minutes out of vertical. So the distance from here, which is where the receiver actually is, to here, where the receiver should be, is the horizontal difference, or the horizontal error. There's not a formula for that in your book, but basically if you look at this as being a right triangle with a hypotenuse of 2 meters and an angle of 10 minutes, you can see what the distance is between where the receiver is and where it would be if it were totally vertical, which this is the opposite to that angle. This side is the opposite, so the horizontal error side is opposite 10 minutes with it in a triangle with hypotenuse of 2 meters. So we know that opposite over hypotenuse is a sine of an angle. That means that the opposite, the horizontal error over the hypotenuse, which is the 2 meters, is equal to the sine of 10 over 60, or 1/6 of a degree. So if you compute this, the hypotenuse of 2 meters, you just cross multiply, and you get that the horizontal error is 0.0058 meters, which turns out to be 5.8 millimeters, because there are 1,000 millimeters in a meter. Now, for the vertical error, you can see it's a little bit more complicated. It's this chunk that is different between where the receiver would be in the vertical direction as opposed to where the vertical distance above the point of the bottom of the receiver. So in this particular case, we have a formula in the textbook which tells you that it's r, which is the height of the pole, minus r times the cosine of theta. Now if you think about what cosine of theta is, cosine is adjacent over hypotenuse. So this distance is r cosine theta, and this distance is r. So the vertical distance, which is just this wee little chunk right here, is the difference between those two. So if we take r, the length of the pole, and subtract r times the cosine of theta, we get 2 meters minus just almost 2 meters, just barely under 2 meters. Because if you remember, the cosine of 0 is 1, so the cosine of this tiny little angle is actually closer to 1. So the distance turns out to be 8.462 times 10 to the negative 6 meters, which is 8 times 10 to the minus third millimeters, or 0.008 millimeters. All right, so I hope that this is helpful to you. Please let me know if you have any questions, and I'll look forward to talking to you soon. Thanks.